Hello everyone. In this session we are going to discuss about the alkalinity of water sample. So what exactly is alkalinity? Alkalinity of any substance can be defined as its acid neutralizing capacity. So we know for measuring acidity or alkalinity of a compound, we can use a pH scale. That means if any substance has pH below 7, from 0 to 6, we say it is an acidic substance. If the pH of that substance is 7, we say it is neutral. While if the pH is above 7, that means from 8 to 14, we say that substance is alkaline or basic in nature. So water sample also has alkalinity, and it is due to presence of certain compounds. Which compounds are those? So water has alkalinity due to presence of hydroxides, bicarbonates and carbonate compounds which are dissolved in water. So let's have a look at the examples of each. So hydroxides which can be dissolved in water are like ammonium hydroxide, calcium hydroxide and magnesium hydroxide. Few examples are given. So if hydroxide compounds are present in water, if they're dissolved in water, then it will make water sample alkaline. That means it will make its pH higher, more than 7. It can contain carbonate salts as well, like calcium bicarbonate, magnesium bicarbonate, ferrous bicarbonate, and sodium bicarbonate. Plus, it can contain carbonates like magnesium carbonate, ferrous carbonate, and calcium carbonate. So, if this type of salts, if they are present in water, then it will make water alkaline. Also, depending upon which salts are present, which types of salts are present in water, there are different types of alkalinity of water. Like if water contains only hydroxide salts, then it will be only hydroxide alkalinity. If water contains only bicarbonate salt, then it will be only bicarbonate alkalinity. If it contains only carbonate salts, then it would be only carbonate alkalinity. So three types are here depending upon the three salts. Also, water can contain the mixtures of the salts also, right? It can contain a mixture of hydroxide and bicarbonate. It can contain a mixture of hydroxide and carbonate, or it can contain a mixture of hydroxide and carbonates. It can contain a mixture of carbonate and bicarbonate. So three salts are there, three possibilities are there. So total there can be 6 types of alkalinity. But if you see, there are only 5 types of alkalinity. So which are they? First is only hydroxide alkalinity. Second is only carbonate alkalinity. Third is only bicarbonate alkalinity. Fourth is mixture of hydroxide and carbonate alkalinity. So hydroxide and carbonate can be present. This is one type. So another type which is present is carbonate and bicarbonate alkalinity. Okay, which is not present. So hydroxide and bicarbonate alkalinity is not possible. Why it is not possible? Because if water sample contains hydroxide and bicarbonate, you can see here the reaction. They will react to form carbonate ion plus water molecule. So it is forming carbonate ion plus water, means this comes under the type of only carbonate alkalinity which we have already considered. Also, if all the three salts are present in water together, then they will form ions. Okay, so these are the mainly three salts or three compounds which are responsible for the alkalinity of water, that is hydroxide salts, bicarbonate salts and carbonate salts. So let us have a look that how we can find the alkalinity of water sample. As I said, alkalinity can be defined as acid neutralizing capacity of water. So if we have to find the alkalinity of water, we need to titrate it with acid. So we will titrate it with sulfuric acid, and depending upon that how much acid is required for neutralizing that water sample, we can find the alkalinity of water sample. So let's understand this further, that what is the theory of this titration reaction. So first, what is going to happen when we are going to titrate a water sample with an acid? Neutralization reaction is going to take place because water is alkaline. We are reacting it with acid, and we know when acid reacts with base, we get salt plus water. Okay, so that reaction is called as a neutralization reaction. So in this titration also, neutralization is going to take place because we are going to add strong acid from burette into a water sample. So first, all the hydroxide ions present in water will get neutralized. Once they are neutralized, then all the carbonate ions which are present in water will get half neutralized. And once this carbonate ions are half neutralized to bicarbonate, then the bicarbonates which are actually present originally and those which we have get from carbonate will get neutralized. Okay, we will understand this more easily with the help of reactions further. Also, since this is a titration reaction, we need indicators. So one indicator which we need is the phenolphthalein indicator to find the endpoint. So when the neutralization of hydroxide and half neutralization of carbonate ions is taking place to bicarbonate, we use the phenolphthalein indicator because phenolphthalein shows a color change in the pH range 8 to 11. Okay, so hydroxides and half neutralization of carbonates takes place at around pH 8.2. That is why the first indicator which we are going to use is the phenolphthalein indicator. Now, the remaining bicarbonates which are there in water and the bicarbonates which we are going to get by half neutralization of carbonates, those are neutralized in presence of another indicator which is called as the methyl orange indicator, which is having a pH range of 3 to 5. So the bicarbonates get neutralized from pH 4 to 5. That is why we are using methyl orange indicator. Okay, so hydroxides and half neutralization of carbonates takes place when we are using phenolphthalein as an indicator. So it is also called as phenolphthalein alkalinity and it is denoted by P. Similarly, bicarbonate ions which are originally present in water and which we get by half neutralization of carbonates are neutralized when we are using methyl orange as an indicator. So it is also called as a methyl orange alkalinity, which is denoted by M. So what are the reactions, neutralization reactions which are taking place? As we said, first when we add acid to the alkaline water sample, hydroxide ions are the most basic of the three ions. Hydroxide, carbonates and bicarbonates. OH minus ions are the most basic. So they are going to react first with acid and get neutralized to form water molecule. Since we are getting water molecule directly here, we are saying it is the complete neutralization. Complete neutralization is going to take place. Second, the carbonate ions. Once the hydroxide ions are completely neutralized, the carbonate ions are then going to react with the H plus ion from the acid to form bicarbonate. So you can see it is forming bicarbonate here. Okay. Carbonate ion is reacting with acid to form the bicarbonate ion. Means we are not getting water as a product. So this is half neutralization. And then in third step, the bicarbonates which we are getting from carbonate as well as the bicarbonates which were already present in water sample will react with acid to form H2O plus CO2. That means in this case the complete neutralization has taken place. Okay, so this is the reaction which is going to take place. Since it is neutralization reaction, the titration is neutralization titration. Also, hydroxides and carbonates are going to get neutralized. Hydroxide complete neutralized and carbonate half neutralized in presence of phenolphthalein as an indicator. So we also called it as phenolphthalein alkalinity denoted by capital P. While bicarbonates are going to get neutralized when we are using methyl orange as an indicator. So we also called it as methyl orange alkalinity denoted by capital M. Okay. So now let's see how this is going to happen exactly. So this is a conical flask. In this we are going to take a water sample, suppose 25 ml of alkaline water sample whose alkalinity we need to find out. Okay. Here in burette we are going to take sulfuric acid solution. We need to titrate it with acid. So we'll take a acid solution of known concentration and first in water sample we will add the phenolphthalein indicator. As soon as you add the phenolphthalein indicator, if water contains hydroxides and carbonate salts, so pH would be much more than 8. So when we add phenolphthalein indicator in this water sample, it will show us pink color. Okay. So then we will add acid from this burette into this flask until this pink color changes to colorless. So the amount of acid which we have taken until the phenolphthalein changed its color from pink to colorless, so that we will note down. After that, we will add in the same water sample, we will add 1 or 2 drops of methyl orange indicator. So this will be yellow in color. Okay, so this is our first part. In water sample, we add phenolphthalein indicator. Until the phenolphthalein changes its color from pink to colorless, we add acid. Okay, and we note down the volume of acid required. Suppose it is V1. Then in the same water sample, we add methyl orange indicator. It shows yellow color. And in this conical flask, we again add drop by drop acid until it changes its color from yellow to orange. And we note down the ml of acid required for methyl orange to change its color from yellow to orange as V2 ml. Okay, once the readings are taken, then let's see how we will find the alkalinity. So what is the procedure and calculation? So we have taken V ml of alkaline water sample in the conical flask. First we add 2 drops of phenolphthalein indicator in it. Then we titrate it with an acid and we know the concentration of acid. Suppose it is Z normal, and we add acid till the color changes from pink to colorless. And then we note down the ml of acid required for the color change. In the same conical flask, we add methyl orange indicator. So the color changes to yellow, and we titrate it with acid until the color changes to orange. And we again note down the V2 ml of acid which is required for its color change. So after noting V2 and V1, actually how it is taken. So if while performing the titration, I required V1 ml, that is 2 ml of acid for phenolphthalein to change its color from colorless to pink. And further, when I continued the titration after adding methyl orange indicator, I required further 4 ml of acid for methyl orange to change its color from yellow to orange. So V2 would be 2 plus 4, means the total amount of acid required for complete titration is taken as V2. Okay, once we get the value of V1, V2, how we can calculate phenolphthalein alkalinity and methyl orange alkalinity? So this is the formula. P would be equal to V1 into Z. So V1 is the volume of acid required for phenolphthalein endpoint into Z, normality of acid, into 50 into 1000 upon capital V, which is the volume of water sample taken, and we will get the alkalinity in ppm of calcium carbonate equivalent. Similarly, for methyl orange alkalinity, instead of taking V1, we will take V2, which is the amount of acid required for methyl orange to change its color from yellow to orange. That is the complete amount of acid required for the titration, and into Z, that is the normality of acid, into 50 into 1000 upon capital V, which is the volume of water sample taken. Once we get the value of P and M, you can see there's a table here. In this table, you have to put the values, and accordingly you have to find the type of alkalinity present. Like if P is equal to 0, then the type of alkalinity would be hydroxide is 0, carbonate is 0. It will have only bicarbonate alkalinity, and the amount of bicarbonate alkalinity would be equal to. We will understand how we can calculate alkalinity by solving the numericals in the next session. Also, for better understanding of how this titration is performed in the laboratory, I'm sharing a link of my video session in the description of this video. So you can go and check it for better understanding. Thank you.